Hello and welcome to our lesson on odds. I'm sure you've said this yourself or you've at least heard somebody else say it. What are the odds of that happening, right? What are the odds of something happening? So odds and probability are definitely related. The same numbers that we're using in probability are going to be incorporated into finding odds. But you may not know that odds can be given in two different ways. We have the odds in favor of an event occurring, and we also have odds against an event occurring. So when you hear odds, it's important to know if they're odds that are in your favor or if they're odds that are against you to determine whether or not your probability of winning or losing in whatever the situation is good or bad. Okay, so when we look at odds in favor is going to be a ratio. So a ratio, that's a fancy word for a comparison of two numbers. Sometimes we compare numbers like this, we say 1 and 4, or sometimes we compare numbers like this, 1 to 4. This is going to be the way we are going to see ratios written for odds. Okay, we write a ratio for odds using the colon, but it's just a fancy way to compare two numbers. So the odds in favor of an event occurring is going to be a ratio, so it's a number and then a colon and then another number of what we're going to generalize as successes to failures. That is, things we want to happen versus things we don't want to happen. So we'll call the things we want to happen successes, and we'll call the things we don't want to happen, which would be not a success, a failure. Okay? And then odds against an event occurring is the exact opposite. Still a ratio, still a comparison of the two numbers, but it flips the two numbers. So odds against would be a ratio where we put failures first. That's the things we don't want to happen, and then we put successes next. Okay, now in a ratio, the total in the ratio is going to be equal to the total number of outcomes in the event. And a ratio, just like a fraction, can be reduced. So it's going to reduce just like a fraction. Okay, so let me just give you an example really quickly. Let's say we had odds in favor, okay, odds in favor of some event A occurring. So odds in favor of, let's say, event A. Let's say that those odds are 4 to 1. Oh, actually, let's make it this. Let's say they're 8 to 2. So in the same way we could reduce a fraction of 8 over 2 to 4 over 1, we could reduce this ratio. We could say this is the same thing as 4 to 1 odds. Now, because they're odds in favor, that means there are 4 successes for every 1 failure. Okay, because they're odds in favor, it's successes to failures is what we want to happen first, and then favor, and then failures, what we don't want to happen next. So 4 successes to 1 failure. That means the total number of outcomes in this situation is 5. So this is a total of 5 outcomes. Okay, 4 successes and 1 failure is 5 outcomes. So if I wanted the probability of a success, a win, what we want to happen, well, there are 4 successes out of the 5 total outcomes in this ratio. If I wanted the probability of a failure, okay, then in this case there's 1 failure out of the 5 total options. Okay, and then all of this is the same. If it's odds against, it just gets flipped. So if it was odds against event A occurring, then it would be a 1 to 4 ratio, and then it would be failures first and successes next. Okay, so let's look at some more examples. Let's say that a 6-sided die is being rolled, and we want the odds in favor. So odds in favor means we're going to put successes first, and we're going to put failures next. Okay, what are the odds in favor of rolling in this first option here, of rolling a 4? So in a 6-sided die, there are 6 total options, which means every time we make a ratio here, there should be a total of 6, unless it gets reduced, but originally a total of 6. So in this case, a success would be a 4, and then a failure would be not a 4. So how many successes are there? How many 4s are there? There's 1. And how many are there that are not 4s? There are 5. And again, there's your total of 6. Okay? So success would be rolling a 4. A failure would be not rolling a 4. So that means the odds in favor here would be 1 to 5. That is, just trying to make sure you have good notes here. This would be a 1 to 5 ratio. That's 1, 4, and then 5 not 4s, right? 5 numbers that aren't 4. I don't know if that makes sense. I'm just drawing arrows all over the place. Okay, so 1 to 5, and that's not reducible. Part B says, what are the odds in favor of rolling something that's greater than 2? So greater than 2 would be like a 3, a 4, a 5, or a 6. So there are 4 options there. Those would all be the successes of actually rolling something greater than 2. So 4 successes, and then not 2s would be the 1, or not greater than 2 would be the 1 and the 2. That's 2 different options. So this is going to reduce to 2 to 1, and this is, again, 4 options that are greater than 2, and then this would be not greater than 2. Not greater than 2. Okay, but the final answer in this one is the 2 to 1 that we reduced. The final answer here was 1 to 5. Okay, how about the odds in favor of rolling an even number? Well, how many evens? So rolling an even number, this would be a success. Okay, how many evens are there? In the 2, 4, and 6, there's going to be 3 evens. And then how many not evens? Well, there are 3 of those as well. So 3 to 3 ratio, that's our total of 6, but that's going to reduce to 1 to 1. So we have 1 to 1 odds in favor of rolling an even. How about a 3 or a 4? So rolling a 3 or a 4 would be a success. That's 2 different options. That means the other 4 options are the failures, and that's going to reduce to 1 to 2. So we have 1 to 2 odds in favor of that happening. And how about a number less than 6? So a success would be rolling a number less than 6. So 1, 2, 3, 4, or 5. That's 5 options. And if there are 5 of them that are successes, then the other 1 that's left is a failure. So we have 5 to 1 odds, and that does not reduce. Okay? How about a multiple of 3? Do you know what a multiple of 3 is? A multiple of 3 means, like, 3 times 1 is 3. That's a multiple of 3. 3 times 2 is 6. That's a multiple of 3. 3 times 3 would be 9. That's a multiple of 3. So those are all multiples of 3s, but in our 6-sided die, the only ones that come up would be a 3 or a 6. So that's 2 options. 2 options that are successes, which means the other 4 have to be failures. And that's going to reduce to 1 to 2 odds. Okay, so 1 to 2. Hopefully that's not too bad. And I don't know if what I've done in red here is confusing, less confusing, more confusing than, I don't know if you're going to come back to these notes and how you're going to look at it, but I think what I was doing here was a little bit more helpful. So this would be a success, and that's 2 options there. And this would be a success, that's just the 1 option. And then a number, let me move this over. A number greater than 2, that's a success. And that would be 3, 4, 5, or 6. That's where those 4 options came from. And then here, lastly, let me see if I can scooch this again just a little. Okay. And lastly here, an even number would be a success, so your successes were 2, 4, or 6, so 3 options. Okay? So same thing on the next one, except instead of odds in favor, we're going to be looking for odds against. So odds against means we're going to put the failures first, and then we're going to put the successes next. Okay. Now we're going to be selecting one card from a standard deck. There are 52 cards in a standard deck. That means the total in our ratio should be 52. Just like over here, we should have a total of 6 because there are 6 options when we roll the die. Over here, this is a standard deck, so we should have a total of 52. Now again, it could reduce, but originally we should have a total of 52. Okay, so odds against, failures first, successes next, although it's easier to count the successes. So here, let's see, a face card. A face card, let's call those successes, right? Pulling the face card would be a success. How many face cards are there? Well, there are 12 face cards, which means there are 40 that are not. So in this one, we have 40 failures, not face cards, to the 12 face cards, which are the successes. So 40 to 12, and that's going to reduce. And let's see, 40 to 12. You can just put it in as a fraction, and 40 to 12 is going to reduce to 10 to 3. So we're going to have 10 to 3 odds against this occurring. Okay. Rolling a 5, if that's a success, that's how many are there? How many 5s are in the deck? There are 1 in each suit, so 4 of them. So we're going to have 4 successes, 2. The rest of them are not going to be 5s. That means the other 48 cards are not going to be 5s. Those would be our failures, and failures are going to go first. And that's going to reduce to 12 to 1. So we have 12 to 1 odds against picking a 5. How about picking a heart? So if that's a success, how many hearts are there? There are 13 hearts in the deck, and so 13 successes, which means the other cards are failures. And let's see, 52 minus 13 is going to leave me the other 39 cards. So 39 to 13, and again, if you want to reduce this using a fraction, you can. That's going to be 3, which is 3 over 1. So this would be 3 to 1 odds against selecting a heart. Okay, how about selecting a black card? So if a black card is a success, and there are 26 black cards, there are 26 successes. Well, the other 26 cards are not black, they are red, and so those are going to be 1 to 1. Oops, 1 to 1 odds when we reduce. 1 to 1. Okay, and then how about a 7 or an 8? If it's a 7 or 8, if that's a success, there are 4 7s, there are also 4 8s. That means there's 8 total successes here. So if we have 8 successes, then the rest are going to be failures. So 52 cards minus the 8 successes would leave us 44. And 44 to 8 is going to reduce to, I still want blue here, 11 to 2 odds against rolling a 7 or an 8. Alright, how about a Queen of Diamonds? The Queen of Diamonds is a success. How many Queen of Diamonds exist in the deck? Well, that's just 1. So we have 1 Queen of Diamonds. That means the other 51 cards are not the Queen of Diamonds, and that's not going to reduce. So the odds of picking, the odds against picking the Queen of Diamonds are 51 to 1. Okay? Hopefully so far this is making some sense. And I didn't finish my box here. Okay, so let's look on the back. I think we're going to try to connect some of this to some probability now. Alright? So the odds in favor of winning a certain scholarship are 1 to 4. So if this is odds in favor, that means we have successes and then we have failures. So if the odds are 1 to 4, that's 1 success for every 4 failures, and that is a total of 5 outcomes. Okay, so it says, what is the probability of winning? So the probability of winning is going to have to be the number of successes over the total. Okay, so how many successes do we have? Well, we had 1 success here, and we had 5 things happening total. 1 success and 4 failures was 1 success out of 5 total options. So there's a 1 in 5 chance, a 1 in 5 probability of winning. So 1/5 is our probability, or if we wanted the decimal, that's 0.2, or if we wanted the percent, that's 20%. So there's a 20% chance that this scholarship is won. Okay? How about the next one? We have the odds against. Odds against are going to be failures and then successes. So the odds against a horse winning a race are 18 to 1. So 18 failures to 1 success. That is a total of 19 outcomes. Okay, so this one says, what's the probability the horse wins and the probability the horse loses? So the probability of winning is going to be the successes over the total, and the probability that the horse loses is going to be, try to be uniform here, is going to be the failures over the total. Okay, so in this case, successes, well, there's only 1 success, and the total was 19. So there's a 1 in 19 chance of the horse winning, and there were 18 failures out of the 19 total. So the probability that the horse loses is 18 out of 19. And again, just move this stuff around. Okay. How about number 5? We have the probability of an event occurring is 2/3. So if the probability that an event occurs is 2/3, the 2/3 tells you if the event occurs, this is 2 successes, and this would be 3 total outcomes. Okay, so what else does this tell us? Well, if there's 3 total outcomes and 2 of them are successes, then from this we also know that there is 1 failure, right? There's 3 total things. If 2 of them are successes, the last 1 thing has to be a failure. Does that make sense? I hope. Okay, so what is the probability that the event will not occur? So if 2 out of 3 times it does occur, then 1 out of 3 times it does not. Okay, the odds against are going to be the failures to successes. So that would be 1 failure to 2 successes. And the odds in favor are successes to failures. So that would be 2 successes to 1 failure. And I think, oh, holy cow, that is it. Okay, so you might have to watch that again if you feel like I went kind of quickly here. But just make sure that the total that you're looking at in the probability, that is the same total in your ratio. And odds against puts the failures first. Odds in favor puts the successes first. Successes being what we want to happen, failures being what we don't want to happen. Okay? Hopefully that makes sense. That was a quick one. You've got some practice problems to try out, so if you need some help, as always,